Hello and welcome to my YouTube channel Nady the Coder. In today's lecture we're going to be talking about string data type. We'll talk about different methods of string and we'll talk about how a string is stored in JavaScript. Before we dive into the lecture, please make sure you watch the previous lectures on JavaScript in order to follow along. Let's just dive into the lecture. So in JavaScript, the textual data is stored as a string. There is no separate type for a single character. The internal format for strings is always UTF-16 and it is not tied to the page encoding. Let's recall the kinds of quotes. So a string can be enclosed within either single quotes, double quotes, or backtick. You can see all of these different types of quotes. The single and double quotes are essentially the same. Backticks, however, allows to embed any expression into the string by wrapping it in the pair of braces. For instance, let's say that we have a function. The function name is basically sum. And it takes two arguments, a and b, and it returns the sum of two numbers. We can call the sum number like this, and we can pass any numbers that we want in order to add them. We will just simply store the result of these two numbers into a variable called result, and we can simply print the result like this. But let's just make the result more descriptive. So I'll remove the result variable, and instead of that, I'll just put the numbers. Through these curly braces, I can embed any expression into this string. So in here, I'll just pass the result. That is basically the result of the two numbers. I'll save this file and you can see that we have the result 1 plus 2 equals 3. Another advantage of using backticks is that they allow a string to span multiple lines. So let's say we have a string like this, then we can put it in multiple lines like this. It won't cause any errors. And it looks natural, yeah? But single or double quotes do not work this way. If you use them and try to use multiple lines, there will be an error. Let's say if I use double quotes over here, when I save the file, when I refresh, you can see invalid or unexpected token over here. Single and double quotes come from ancient times of language creation, when the need of multiple strings was not taken into account. Backticks appeared much later and thus are more versatile. Let's talk about special characters. It is still possible to create multi-line strings with single and double quotes by using a so-called new line character, written as \n, which denotes a line break. Let's say we have a string like this that is basically a guest list. I have multiple names over here and I want to print these names on multiple lines. So in order to do that, I'll just make use of the new line character. You can see that we have all of the names in separate lines. Looks perfect. Basically, all special characters start with the \ character. It is also called an escape character. We might also use it if we wanted to insert a code into the string. Let's say we have a text that basically says I'm the Jackson, and you can see that it's been wrapped in the single quote. What if we wanted to add a single quote inside the string? So if I add one, you can see that it's giving some error that says expected this, but even when I save it, you can see there is an error. In order to solve this problem, I should be using the quote character over here, and I can just replace it with the \. You don't see any error over here. And when I try to print it, you can see that I'm getting the string with the quote that I just escaped by the \. As you can see, we have to prepend the inner code by the \ because otherwise it would indicate the string end. Of course, only the quotes that are the same as the enclosing ones need to be escaped. So as a more elegant solution, we could switch to double quotes or backticks instead. As you can see, if I'm using backticks, that I don't need to use the escape character. Just keep in mind that the \ serves for the correct reading of the string by JavaScript. It then disappears. But what if we need to show an actual \ within the string? And that's a possible use case. Let's say we have this case where we have two names and I'm separating it by the \. You can see that we are not getting the \ over here, but instead we're getting just an empty string. In order to print the first \, I'll have to add another \ over here. You can see that we are seeing the \ over here now. Now let's talk about the string length, how we can identify the length of the string. The length property basically on string has the string length. Let's say we have this string and I want to find out the length of the string. I can simply put the variable name over here and then dot, and I can then specify the property length, which will give me the length of that string. You can see that length of the string is basically 12 over here. Now what happens if we have a special character in the string? Let's say we have a new line special character over here and I want to identify the length of that string. Then when I refresh, you can still see that we have the length 12 over here. That is because that the special character new line or any special character that you have used in your string is a single special character, so the length is indeed 12. Also keep in mind that people with a background in some other languages sometimes mistype by calling string.length as a function like this instead of just writing it as a property like this, and that doesn't work. Please note that the string.length is a numeric property, not a function. There is no need to add parentheses after this. Now let's talk about accessing characters. To get a character at a specific position, we can use the square brackets and identify the position of the character that we want to access, or we can simply call the method that's called string.character@, and then we have to pass the position. That is basically a number, and it will give us that specific character. Also keep in mind over here that the first character basically starts from 0 position. So let's say we have this hello string over here, and I want to get the first character out of here. I can simply do something like this, which is basically text as the variable name, and then I'm putting the square brackets over here. I'm specifying the position of the character that I want to access. So basically H has the 0th position, E has first position, L has second position, then the second L has the third position, and O over here is 4. And in a refresh, you can see we're getting the H character. If I want to print all of the characters like this, you can see I'm starting from 0, that is basically H. The second call will just give us E. Third call will give us L. The fourth call will give us a second L. The fifth call will give us O. You can see we're getting each characters like this. If you don't want to make use of the square brackets, then instead we can call a function or method on the text that is called character@, and we have to specify the position of the character we want to access. So when I save this, when I refresh, you can see I still have access to the H, the very first letter. And if I want to print all of them from the string, you can see that we're getting all of the characters over here like this again. Now, since we know that we can get the length of the character by just specifying the length property on the string itself, what happens now if we want to access the last character of a string? So in order to do that, I can simply make use of the square brackets like this. And within here, you can see that we want to access the last character over here of the string. And if I give it numbers, so you can see 0 stands for H, 1 stands for E, 2 stands for the first L, 3 stands for the second L, 4 stand for the O, and the length of the string is basically 5. That's because it has 5 characters. So we can simply say whatever is the length of the text minus 1, it will give us the last character. So when I refresh, you can see we're getting the O, that is basically the last character. And it will not just work for this string specifically, but any kind of string of which you want to access the last character. The modern way of getting the last character or any character from the string is basically that we have to call a method on the string itself that's called add, and we can specify the position. But if I want to get the last character out of the string, then I just have to specify -1 over here. And when I save it, you can see we still get the last character. And if I specify over here -2, then you can see that we are getting the second last character over here. And if I want to print this whole string in a reverse order like this, so I want to go from the end to the start like this. So you can see -1 is basically O, -2 is basically the second L, -3 is basically the first L, -4 is basically the E, -5 is basically the H. When I save this file, you can see it's been printed in reverse order. The square brackets here is basically a modern way of getting a character, while character exists mostly for historical reasons. The only difference between them is that if no character is found, the square brackets returns undefined and the character @ returns an empty string. So let's say we specify a number or a position that's not basically within the string, or which is basically greater than the length of the string. When I save the file, you can see we are getting undefined for the first call, and in here we are getting an empty string that's not visible actually. Strings are immutable. Strings cannot be changed in JavaScript. It is impossible to change a character. So let's try to show that it doesn't work. Let's say we have a string that is called hi, and at the 0th position I want to assign a lowercase h, and then I want to print the 0th element that is just modified over here. So it should be a small h and not a capital one. But when I save it and refresh, you can still see that I'm getting h. So it means that you cannot actually modify or mutate the strings. The usual workaround is to create a whole new string and assign it to the string itself instead of the old one. So instead you can see that I'm reassigning the h and then the string value on position 1, that is basically I. And in here I'll just print out the string. When I save this and refresh, you can see that now we have the new value that we're expecting. Now let's talk about changing the case. Methods like dot to lowercase and to uppercase change the case of a string. So if you want to change this string to lowercase, so all of the characters will be made lowercase, you can simply do string dot to lowercase. You can call this function on that. Or if you want to make the whole string an uppercase, then you can simply call the to uppercase method on the string itself, and it will give you the uppercase letters. When I print it out, you can see that the first string is made lowercase and the second string is made uppercase. Searching for a string There are multiple ways to look for a substring within a string. The first method is basically called string.indexOf. It looks for the substring in the string starting from the given position and returns the position where the match was found, or -1 if nothing can be found. So let's say we have this string and the value is basically widget with ID. And let's say I'm searching for the first word that is basically called widget. So I can simply call this indexOf method on the string itself. And I just have to pass the word that I'm looking for basically within the string. And when I console log it or print it, you can see that I'm getting 0. That basically means that this word is found and it is basically on the 0th position. As we already know that the string basically starts from 0. And it goes on. So the first character is 0, the second is 1. What if we are looking for the same word but with lowercase first? And since you can see over here that the first character is basically an uppercase, but in here it's basically a lowercase letter. When I save this, when I refresh, you can see that I'm getting -1. That means that it's not able to find that word. So the case sensitivity over here basically matters. If a character is basically an uppercase or lowercase, then it basically matters. Now, if I want to search for another word that is basically ID, and you can see over here, you can see that we are getting 1. Why is that? That is because ID is present over here as well. That is basically 0, and then ID start from 1 over here. So that's why we are getting 1. And it's not basically returning the position of this ID that we are looking for. But if I add a space over here, you can see there is a space over here before the ID. So technically it should be pointing me to this one. When I save this, refresh, you can see I'm getting 11. But the problem over here is basically the space is counted over here. And 11th position is basically for the space and not the I. So don't just commit a mistake over here. You should be keeping in mind that if you're specifying a space before the ID, then it's basically giving you the index of the space and not the I over here. We also have an optional second argument that we can pass to the indexOf method, which allows us to start searching from a given position. For instance, let's say the first occurrence of ID is at position 1 that you can see. To look for the next occurrence, let's start the search from position 2. So as a second argument, I'll just pass the position that I wanted to start searching from. So in this case, it will skip 0 and 1. So the W and I will be skipped and it will start searching for ID from here onward. So when I save it and I refresh, you can see I'm getting 12 now. That is the exact position of the ID in this string. Now let's say that we have a bigger string over here that says as sly as a fox, as strong as an ox. And we want to find out all of the occurrence of this as word in this string. We can simply loop through this string and find out all of the occurrences of this word within the string. So we are declaring a variable that is called the position, that is basically the 0th one. Since the first character is basically starts from the 0, so that's why we have the position 0 over here. Then we have the while loop, that is basically true forever, and it will loop through this block of code unlimitedly. And in here you can see that we have another variable that is called the found position, and we are calling the indexOf method on the string, that is basically this string, and we are passing the target. So target is basically this string that we are searching for, and the position is basically this position, and we are telling this indexOf method that okay, search for this target word on this specific position. So in the first loop, the position will be 0 and the target will always stay the same because we're not incrementing or changing it within the body. If the found position is basically -1, if this method returns -1, which means this word is not found in the string, then it will return -1 and it will break the loop. If you have the basic idea of loops and how it works and what is a break statement over here, then you would know how we can break out of a loop. And in here you can see that we are alerting the position at which the word is basically found in the string. And also we are incrementing the position basically. So on each loop, it will increase the positions, so we just move forward in the string and we don't loop through the same characters again and again. So on the first loop, the position will be 0. On the second loop, the position will be the found position. At whatever position the as word is found in the string, that will be the position, and we're adding 1 to this. And then at the third loop, it will be again the position of the word that is found. So you can see the first occurrence is here. So it will add this position, basically the position of A over here, to the found position, and it will add 1 to this. So it means that you don't have to look for this word, but you should move onward in this string. The second occurrence will be this as, and then when we print it or alert it, you can see that we are adding 1 again to the found position, basically. So this position plus 1, so it will move onward in this string and it will not look back in the string. This is basically the whole logic of this loop. When I save it, when I refresh, you can see found at position 7, and then found at position 17, and then found at position 27. So we have basically 3 occurrences of this word, and you can see it over here. The first occurrence is this is the second occurrence, this is the third occurrence. And as I told you before, that the case sensitivity matters, so that's why it's not been printed. But if I make it A's, and if I make it a small one, and I save it, and then refresh, you can see found at position 0, then we'll have 7, then we'll have 17, and then 27. So now we have 4 occurrences. There's another method that is called string.lostIndexOf. This method is basically similar to string.indexOf that searches from the end of a string to its beginning, and it would list the occurrences in the reverse order. That is basically the slight difference between the string.indexOf and string.lostIndexOf. There is also a slight inconvenience with indexOf or string.indexOf method. In the if state, let's say we have a string like this which says widget with ID, and I want to find out the word widget within the string. Let's say if it works or not. You don't see anything over here, no output. You can see that the case sensitivity is fine over here. The words are basically the same, but it's still not outputting the alert, or it's not basically executing this block of code. Why is that? The message we found that is not shown in this example because string.indexOf returns 0, meaning that it found a match at the starting position basically. But the if condition, 0 is being considered false. So when this method is executed, it basically returns 0, which means that the widget has been found, the widget word has been found in on the 0th position, which is true actually, but it returns 0, since it's returning the position of the word in the string. That is basically 0 in our case. So 0 for f means false, and it will not execute this statement. So that's why the workaround is to check for -1. And when I save it, when I refresh, you can see we're getting the message we found it. Let's talk about the bitwise not operator. One of the old tricks used here is the bitwise not operator. It basically converts the number to a 32-bit integer, removes the decimal part if it exists, and then reverse all bits in its binary representation. In practice, that means a simple thing for 32 bits integer n equals -n plus 1. So it means if we have some numbers like this, let's say we have 2 over here, but we are using the bitwise not operator on this number, it will give us -3, which is the same as negative of 2 plus 1. Since we said any number that has the bitwise not operator equals -n plus 1. So the same case applies to all these numbers. So in case of 1, it will give us -2 because it is 1 plus 1. That is basically a negative of 1 plus 1. And for 0, it will give us -1. That is basically the same as 0 plus 1. That is negative. But in case of -1, it will give us 0 because -1 plus 1 equals 0, and we don't apply any negation and we don't apply per plus or minus on 0. So in this case, we'll get 0. And as you can see that we are just getting 0 in case of -1. That is for any 32-bit signed integer n. So instead of checking for the -1 value over here, if we get rid of this, and I add the bitwise not operator at the beginning of it, and I save it, you can see that we're still getting this message now. So in here, the bitwise not operator is doing the trick, and people often use it for a shortened index of check. It is basically usually not recommended to use language features in a non-obvious way, but this particular trick is widely used in old code, so we should understand it. Right now, we see this trick only in the old codes, as modern JavaScript provides another method to check for words in string. Let's talk about includes method, starts with method, and ends with method. The modern method string.includes basically returns true or false depending on whether the string contains the substring within. It is the right choice if we need to test for the match but don't need its position. Let's say we have the string and we want to find out the widget if it is present over there in the string or not. We can simply do something like this, and you can see that we're getting true over here. And if we do something like this over here, you can see that we have the hello string over here, and we were looking for the by word within the string. We are getting false actually. So that basically means that this word is not part of this string, or this substring is not basically part of the string. In this case, you can see that we are getting ID. That is basically true because this substring is basically part of this string. But we also have an optional argument that is basically the position of the substring that we want to find out. Let's say we pass 2 over here, then you can see that we're getting false. When we pass 1, it basically returns true because it's able to find it on the ones position. And by specifying 2, we're telling the function to start the search from the second position. Basically 0, 1, 2, basically from D. So that's why it's not able to find the substring ID within the string, and it will return false. The other methods like string.startsWith and string.endsWith do exactly what they say. So they're pretty obvious by their name. So let's say we have this string and we want to find out if it starts with WID. We can simply do this, and you can see that it's basically returning true because the string basically starts with WID. But also you can see that the case sensitivity basically matters over here as well. So if I'm looking for the WID but with a lowercase character at the beginning, then it's returning false. So it means you have to be careful about the case sensitivity over here as well. And a similar way, we also have another method that is basically ends with. So it basically checks if this string ends with this substring. So you can see that basically actually ends with get. You can see it over here. In this case, it returns true. But if I make it case sensitive and make the first character uppercase, then you can see it's returning false because it's not ending with the capital G but the small. Now let's talk about getting a substring. There are basically 3 methods in JavaScript to get a substring. The first one is substring, second one is substr, and the third one is basically slice. Let's talk about the string.slice. It basically returns the part of the string from the start to the end, but not including the end. So let's say we have this string that is basically stringify, and let's say from this string I want to get the first 6 characters. So I can simply do something like this. I can call the slice method on the string itself, and I can specify the start and end position over here. So I want to get from 0 to 5, that is basically 0 is S, then 1 is T, 2 is R, I is 3, and S 4, and the 5th element is basically G. As I mentioned, the 5th character will not be returned. So when I console log it, and I refresh, you can see we're getting strin but not the G, because the string.slice actually exclude the last character. So it will not basically include the character on position 5, that is basically G. What happens now if we don't specify the second argument in the slice method? And I get rid of this and I'll just pass it 0. When I save this and refresh, you can see we're getting the full string. So it means if we don't specify the second argument, so it will start from the first position that you specified over here, and it will go up to the end. Whatever the position is over here, for example, I specified 3 over here, so it will start from the 3rd position, and it will just return the rest of the string up to the end. Basically, negative values for start and end are also possible. They mean the position is counted from the string end. Let's say I specify -4 and -1. So it means to print the string, to slice the string from the end. So -1 is basically this, the last character. -2 is this one. -3 is I. And then -4 is G. So as a result, I should get GIF because the slice method does not include the character at the end position. When I refresh, you can see I'm just getting GIF. And when I put 6, you can see that we are getting this now. If I don't specify the second argument over here again, then you can see that we are getting the string from -6 to the end. The second method is basically string.substring, which returns the part of the string between the start and the end. This is almost the same as slice, but it allows start to be greater than end. For instance, let's say we have the string that is basically stringify, and from this string I want to get the ring substring. Then I can simply call the substring method on the string itself, and I can specify the positions over here. So basically the 2 position is basically S, T, and R. That is basically 0, 1, and 2. So it starts from R, and then it goes up to 6. So that's basically 3, 4, 5, 6. But since it's the same like slice and it does not include the position of last character, when I log the result of this and I refresh, you can see we're getting ring. And if I do something like this over here and I save it, you can see that we are still getting ring because both of them are the same for substring. But in substring, negative numbers or negative arguments are not supported. They're basically treated as 0. The third method is basically called string.substring. And it returns the part of the string from start with the given length actually. In contrast with the previous methods, this one allows us to specify the length instead of the ending position. So let's say we have again this string and I want to specify that, okay, start from the 0 and return 4 characters after this. In order to do that, I can simply do this. I can call the substr method on the string itself and I can specify the position. And that is basically not the end position, but actually the length of the string that I want to get from this string. When I print it and save it, you can see that we are getting stri. That is basically the 4 characters. and that is the length that is specified. The first argument can also be negative to basically specify it from the end to get the substring from the end itself. When I save it and refresh, you can see that we are getting GI. So the position of G basically from the end is -4, that is -1, -2, -3, and -4. And then the length is basically 2. So basically it will give me G and I. And if I want to also get the F, then I have to make it 3. And then here you can see that we are getting GIF. But now the question is which one to choose. So basically all of them can do the job. Formally, substr has a minor drawback. It is described not in the core JavaScript specification, but the Annex B, which covers browser-only features that exist mainly for historical reasons. So non-browser environments may fail to support it, but in practice it works everywhere. Of the other two variants, Slice is a little bit more flexible. It allows negative arguments and shorter to write. So it is enough to remember solely the slice of these 3 methods. Now let's talk about string comparison or comparing strings. As you know from the previous videos that I created for comparisons, strings are compared character by character in alphabetical order. Although there are some oddities that are basically a lowercase letter is always greater than the uppercase, and letters with diacritical marks are out of order. So in the first case you can see that it is returning true because the lowercase letter is always greater than the uppercase, and also in here it's basically returning true because the diacritical marks over here, they're out of order, so there is no such comparison. To understand what happens, let's review the internal representation of strings in JavaScript. So all strings are basically encoded using UTF-16. That is, each character has a corresponding numeric code. There are special methods that allow to get the character for that code and back. The first one is basically string.codePointAt, and then the position of the character that we want to pass. It basically returns the code for the character at a specific position. Let's say we want to get a code for this character. I can simply do this and it will return the code for this character. If I have a longer string and I want to get the code point at as another position, for example 3, you can get 108. If I want to get it for 2, you can get 92. If I want to get it for 6, you can get 100. So for each character, we have different codes. There's a second method that is called string.fromCodePoint, and we have to pass the code actually in order to get the character for that. It basically creates the character by its numeric code. Remember from the first method, we were getting code out of the character, but in the second method, we are passing the code and we are getting the character in return. And also just keep in mind that this is basically the string constructor that we are calling this method on. And that is basically the string itself that we are calling this method on. So there is just a bit different. That is basically the string, and this is basically the string constructor. So let's say if I want to get a character of code 90, you can see that we are getting Z. And if I change it to, for example, 100, then you can see we are getting D. That's basically how it works. We can also add Unicode characters by their codes using the \U followed by the hex code. So it's doing something like this. You can see we're still getting the Z over here. But now let's see the characters with codes from 65 to 220, the Latin alphabet and the little bit extra by making a string of them. So you can see we have an empty string over here and we are looping and starting from 65. That is basically the character code that we want to start from. We want to go up to 220 and you can see that we are getting the character from each code that is basically I. The first one will be 65 and it will be increasing by 1. And we are appending the result to the string. And at the end, we are just printing the whole result. Let's see what we're getting. So when I refresh the page, you can see we are getting all of the alphabets and then some special characters and then the small alphabets and some more characters over here. So as you can see over here, the capital characters goes first, then a few special ones, then lowercase characters, and then the diacritical character near the end of the output. Now it becomes obvious why a small a is basically greater than capital Z. The characters are basically compared by their numeric code. The greater code means that the character is greater. The code for A is basically 97, is greater than the code for Z, that is basically 90. So you can see the character code for A is 97 over here, and the character code for capital Z is basically 90. So when you do the comparison between A and Z, then the codes are basically compared. So 97 is basically greater than 90. That's why we're getting true when we are doing A is greater than Z. So basically all lowercase letters goes after uppercase letters because their codes are greater. And some letters like the O with 2 dots on top stand apart from the main alphabet. Here its code is greater than anything from A to Z. Now let's talk about the correct comparisons. The right algorithm to do string comparison is more complex than it may seem because alphabets are different for different languages. So the browser needs to know the language to compare. Luckily, all modern browsers, including the IE10, requires the additional library that is basically Untitled.js. But since at the time of recording this video, the Internet Explorer does not exist anymore, so we don't need any support for that. But all modern browsers supports the internationalization standard that is basically ECMA 402. It provides a special method to compare strings in different languages by following their rules. The call to the string.locale compare with the string2 returns an integer indicating whether this first string str is less, equal, or greater than the string2 str2 according to the language rules. To basically return a negative number if the first string is less than the string2. It will return a positive number if string is greater than string2, and it will return 0 if they are equivalent. This method actually has two additional arguments, which allows it to specify the language, by default taken from the environment. Letter order depends on the language, and set up additional rules like case sensitivity or diacritical marks and normalization. In many languages, there are symbols that are compared of the base character with a mark above or under it. For instance, the letter A can be base character for all of these characters. So most common composite characters have their own code in the UTF-16 table, but not all of them because there are too many possible combinations. To support arbitrary compositions, UTF-16 allows us to use several Unicode characters, the base character followed by one or many marked characters that decorate it. For instance, if we have an S followed by the special dot above character, you can see it from the Unicode over here. When I hit enter, you can see the S with a dot above it. If we need an additional mark above the letter or below it, no problem, just add the necessary mark character. For instance, if we append a character dot below, then we'll have S with dots above and below. This basically provides great flexibility, but also an interesting problem. So two characters may visually look the same, be represented with different Unicode compositions. So let's say we have S1 and S2. Basically, this is the first S and this is the second S. To both of S's, we are adding the Unicodes. So basically a dot on top and a dot below. And when we print the result over here, you can see that they visually look the same. But when we do the comparison between S1 and S2, we're getting false. And that is basically a problem because of the different compositions of these characters. To solve this issue, there exists a Unicode normalization algorithm that brings each string to the single normal form, and it is implemented basically by string.normalize. And if we apply the normalization on both of this S1 and S2 like this, and then compare them, you can see that we are getting true now, because the strings are now normalized. In reality, this is not always the case. The reason being that the symbol S with the double dots on top on top and below is common enough. So UTF-16 creator is included in the main table and gave it the code. So this is all about the strings, and I hope you have learned something new in this video. Please like, and share the video, subscribe to the channel, and make sure to press the bell icon for future updates. And until then, I'll see you in the next lecture.